Last time on the GT6R build, we made the hood hinge again. Only not in the way you'd probably expect. Obviously it's a car, the hood did have hinges, but due to British Leyland being themselves, we chose to completely re-engineer the issue, maintaining bumper clearance, adding gas struts, and improving rigidity along the way. It was more effort than we expected, to be honest, but with the exception of a couple of small items, it's sorted for now. So let's switch things up today and let the mighty LS4 breathe. In a world of professional builds, it can be very tempting to leave out any setbacks and delays in order to keep up a facade of progress. But that's not real. So, this may get a bit convoluted. Please, just bear with us. We've been slowly working out everything that needs to live under our newly hinged hood, and the last major item is the engine's air intake tubing. We want a cold air intake for efficiency, meaning that somehow we've got to get from up here to down here, avoiding everything in the middle. And since the throttle body is not movable and everything else at least kind of is, let's start there. We already have a throttle body. Came with our engine and is electronic, which is nice. But sadly, it was attached to this intake manifold, which is known to be the worst one you can possibly get, as this literal bottleneck chokes down the engine's ability to breathe by a lot. It's specific to the LS4, and there's likely a few reasons why GM designed it this way. But ultimately, it's kinda hot garbage. How much so? Well, Richard Holdener tested it against a run-of-the-mill truck manifold and found it to be at a 58 horsepower detriment. 58! That's over half our factory power. And it's especially terrible when you realize that the truck manifold he used is the most common one you can get. We do have to keep things in perspective though. Even with this manifold, stock exhaust, and emissions components, the LS4 still made 300% of the power our little car came with. So really, who cares? It's not like we need more power. You know something annoying though? The throttle body being electronic means we need an E-pedal and a compatible fuel injection system, neither of which our engine came with, and because we're likely to go the aftermarket route, this means we need to find an extra $600 versus if we just used a drive-by cable throttle. To be clear, that $600 is doing nothing other than letting us use the suboptimal parts we've got. So that sucks. Let's see if we can build ourselves out of this one. We'll start with the drive-by cable throttle body. Okay, it's just a cheap one, but it's really not that bad. The sensors might need exchanging for better ones later, and the screws will definitely get a couple of tack welds, but on the whole, not too shabby. It won't just bolt to our manifold though, as in the conversion, we've also stepped up from a 75mm opening to 92mm, meaning the bolt pattern has also grown, and although it did come with an adapter, which we could modify, that bottleneck is really going to annoy me now that the potential for flow out here is so much greater. The plan then, and it is okay to call me crazy, is to cut off this section completely, take this little part, weld a tube onto the back of it, and mate that back onto the rest. How simple is that? I thought you were saying just a sec. I'm not sure if I want to do this. Well, we better not need that bit.
You told me that was going to be a 4-inch one.
Yeah, no, I'm going to take it out to. But I mean, you think that's going to do something for flow? since the day we bought our engine, this has been the plan, and I've been really excited to see it come together, as it'll make the LS4 so much more useful to a lot of people. However, making the connection between the aluminum and nylon 6/6 parts is proving to be difficult. This stuff is weird. I've looked into panel bond, various epoxies, screwing, bolting, riveting, backing plates, even plastic welding, and ultimately, some combination of those could get us going, but for how long? The plan before making any cuts was to build a C-shaped component with studs that installs from inside the manifold, has a gasket on the outside, and a flange welded to the new neck so it could all sandwich together. But with a better view of things now, I'm noticing just how little space there actually is to slide in any kind of plate, as we can't modify the runner here at all, and that means we'd be missing out on about half the support we really need. A standoff going down to the timing cover could help spread the load, but think about it. There will be some decent weight on this junction, and if it breaks, we'd have a massive vacuum leak after the throttle position sensor, at which point we would most definitely run lean, and you only need to watch Mike Finnegan to see what that does. So considering all this, in addition to the rest of the holes and castings that still need tidying up, and a serious post-work cleaning, there's quite a lot to be done here just to end up with a part that we'll still be crossing our fingers with. Getting the feeling it's not worth the hassle. Great. I really hate it when things don't go according to plan, but considering how much of the project has actually gone exactly how I had hoped, I guess I can't complain too much. Pending hood clearance then, the most obvious course of action at this point would be to collect our pride and get a new manifold. So we did. What? Well, not completely unreasonable. I would have been happy enough with a used part, and a fellow viewer even offered us his LS1 model for $100. But of course that's US dollars, plus shipping and importing, plus injector adapters because ours wouldn't have fit, so it's actually $300 Canadian. And of course, our new throttle body has a different bolt pattern, so it still wouldn't have fit anyways. The LS2 version would have worked, but regardless, pricing these days is ridiculous, as we're talking about 15-year-old parts that occasionally sell for as much as our engine. Therefore, through more research, I eventually stumbled onto the Speedmaster unit, also sold under the Typhoon name and perhaps a few others. It's available new for less than some of the used OEM options, fits our injectors, clears our hood, has this cool belly plate that can be removed for access, and flows better than a factory LS6 unit. That's crazy, and I'm not even sponsored. We've been building this car for what we thought was a 300 horsepower LS. But with the addition of this manifold and a few other parts that we've been quietly gathering in the background, it's gonna be a very bad day not to be making 400. So, whoops. This then solved one problem and created a whole new one. That 3-inch tubing we made room for? No, it needs to be 4 inches now, and naturally, we don't have space. You know, you could just run 2 3-inch tubes. Sometimes he's not an idiot. It's pretty cramped on the passenger side, but it does appear to be doable, so let's just go for it. This incredibly shiny 3-inch intercooler piping kit was much cheaper than buying the bends individually, and as it also comes with some silicone joiners and band clamps, I'd call it a win. A 4-inch joiner now also protrudes from the throttle body, and we can measure out to it for hood clearance, so we'll know what we have to work with when the whole thing comes off in a second. That's better. Here's the plan. The tubes will splice together at the top and spread out to reach the far sides of the frame. We had thought about going under the rails last time, but due to clearance of the belt and lower coolant hose, over the top makes more sense, and is also in line with the project. We do need to be cautious of the hood struts though, as they install on these ball studs and angle back roughly like this when the hood's shut. It should clear, however, and with the sides turned down one more time, they will eventually terminate with a couple of pod filters. By far though, the hardest part aside from making everything fit in here will be adapting from the 2 3-inch pipes to a single 4. So let's start by cutting this 180 in half using a zip tie. Okay, not really. The tie just provides a straight guide all the way around, which a Sharpie can then mark out and a grinder can finish off. Never actually tried it before, but I've heard it works. Cool, that looks about right. The 45-degree end pieces have now been swapped for some 90s, and we're pleasantly surprised by how they're fitting. We may not even need to do anything to them, but up here, it's another story. To merge the tubes together without creating a bottleneck, we're gonna have to cut on a very precise line. And to find that, we need some cardboard. 2 3-inch rings have had a section cut out of them until the remainder matched up with the 4-inch circle drawn here. So in concept, if we remove the same amount of material from the sides of the 3-inch piping, hammer form the ends to shape, and weld them together, the result should be a single 4-inch collector. Wish us luck. This is essentially what we got going on here. This turns forward to put the filter at the bottom, hopefully allowing us enough room to clear the tire. We're gonna have to check that at a point. The gas strut, it's gonna sit on an angle about like that. So we're clearing the tube with it.
When the hood's closed, and then it moves forward.
And then it comes forward as the hood opens. Yeah. So that all seems to be fine. We've got this cardboard here to make sure that we're clearing the side of the frame. We're clearing the belt. The only place we're hitting is on the fan right now. And I think that what we just need to do there is take this piece, trim a little bit off the back of it. So that's easy enough to do. Trim a little bit off the back, that'll slide back a little bit. This will come back a little bit and it should open that up. And once we've got this fitting in here exactly the way we want, then we can mark up this piece in this area for where we need to take that little slice off the side of it and then match the other side up. This belt tensioner obviously is not over on that side, so we got to make sure we clear the bottom of it. Technically they don't have to be fully symmetrical. This side could bend slightly differently to clear its stuff relative to this side, which could bend to clear its stuff. So I mean, it would be a subtle enough difference that you wouldn't really notice it, but I mean, let's try to get it done, right?
Sure.
It would appear the handy-dandy zip tie technique is actually fallible, as evidenced by that piece taped on the side. But at least we can just weld it back on in a moment. On the whole, I mean, hey, this is kind of cool. So these are some of my very first practice welds on aluminum. I think that was bad gas, just because we haven't used the TIG in a while. First one, second one, third one, I touched the tungsten, and then the fourth one here is all right too, but I'm starting out cold and I'm ending up hot, so I got to get better control over the foot pedal. But these are actually better looking practice welds than I was expecting to have, so just to keep things moving, I'm just going to start by actually tacking together the piece that we're working with, just so we can keep the project moving along, and as things progress I'll come back and weld it up. But that's not terrible. So those aren't tacks. I've yet to try a tack, so I gotta have my filler ready. I don't think I can just fusion weld it. And these are just tapes together on the inside, so the tape's probably gonna try to catch fire. So this could be fun, but let's just give it a try, I guess. I don't know whether I should start on the crack or beside the crack. All right, there's a tack.
Very nice.
Tape wasn't too happy about that, but it's adequate.
Trying to get a bit of weight there so the part doesn't move around while if he sticks.
If he sticks.
Yeah, I know.
When he sticks.
No. If. It's if.
You good?
Yes.
Well, that didn't work. Touched the filler to the end of the tungsten, and when you do that with aluminum, it balls up fast. Great. Well.
Okay. Time out.
Okay, things would almost definitely have gone smoother if I made any more than one practice run, but what you gonna do? Time's a-wasting, and we're running out of argon. So I tried my hardest not to suck, and we did eventually end up with a few beads that are at least holding things together. Unfortunately, there is this split on the interior surface, which I eventually noticed was due to the welder's frequency setting being too high, so won't do that again. But anyway, after finishing up all the welds, the Dremel was used to get a nicer finish, and we'll likely go back over it again to fill in some of the low spots later. For a first attempt though, it's what we've got. Ha! No, you don't get to see that. Moving on. Reattaching this bit proved to be so difficult that I didn't even want to record it for fear of irreversibly shaming myself. However, it's clear from the results that we've got some more work to do. The basic part is taking shape though, and if you can overlook my welds, it's actually kind of interesting. So with the welder's frequency now finally adjusted, thank goodness that side piece is fully welded up. And the other two beads also got readdressed, which means they're a bit less ugly now. It's kind of embarrassing to post your learning experiences on the internet for all to see, but at least the aesthetics here don't really matter too much, as it's all just to provide some base material for the Dremel to take down smooth. I guess the old saying really does ring true. A grinder and paint make me the welder I ain't, even if it actually just gets polished up again rather than painted. Or however that goes. We'll come back to the main welds in a bit, as after quickly tidying up the end with some Scotch-Brite, that at least looks better than before. And although it still appears to be a bit wonky, let's move on and just address that on the next piece, which also needs welding up. After this whole fiasco then, I'm taking extra time here to make sure these are as symmetrical as I can get before we place a couple of tacks on the edges and another one in the middle to pull up the remaining gap. It's becoming apparent that I'm a marginally better TIG welder when the camera's not running, so we quickly knocked out the rest of this piece and the results are passable. It got a little hot near the end, and even 100 amps was still too cold in the middle. But I'm really not too worried, as I think the TIG welder has finally conquered my OCD. That gets those two pieces welded up. So it is then a matter of joining the two. And that will be the next fun task, because as you can see, there's a little bit of a hole in the middle.
A little bit of a hole. I can see right through.
Ironically, the bottom looks better. That's a lot of a nicer fit up on the bottom. Now, this also is taller and maybe a little bit narrower than its corresponding piece. So what I'm hoping is that we can actually fix both those problems by pinching these together as we tack and go clamp there and try to oval this out a little bit, which will line it up better with this, rather than trying to punch this out somehow. I think it'd be easier to clamp that down. But that's literally one of our next steps.
Yep.
And that's what that little part's gonna look like. And just like that, it's now completely finished up. And although I'm sure it would be stronger to have left the welds alone, trust me, that wasn't an option. Even after all that work, you can still see some ghosting and low spots, unfortunately, so our original plan of polishing this seems pointless. But I think some quality filler and a splash of paint will still make for a nice finish. It just feels ironic to have painstakingly polished some aluminum parts to then paint these. But I guess that's just how it goes sometimes. Regardless, it's great to have this part more or less done now, and although some clearances are very, very tight indeed, with the tensioner being the most annoying area, this really is the best we could do while keeping it all symmetrical. I think the idea of a fan shroud might just have been put on the back burner though. Anyway, let's push on with our last step for today and get the sides buttoned down with some brackets. And we'll follow a similar build construction to what we used with the exhaust hangers, as we still have a few bushings left. So, with those bolted up, that finishes off the entire intake system, all the way from the dual filters to the Y and through the new manifold. Not bad. We'll likely come back and roll a bead into the neck up here later so we can get a better seal, but although it may be a bit rough in places, it's actually pretty solid, with no loose bits waiting to fall into our motor, and even if a joint does crack eventually, at least it won't create a vacuum leak. On the whole then, that's pretty good progress. So let's call it there and wrap up a few remaining tasks next time, after which we'll be on to a whole new phase. Stay tuned then, and thanks for watching. Very special thanks to all our amazing patrons and donators who support this project, and if you'd like to help out as well, there are links in the description below. Keep wrenching, and we'll catch you next time. We just modified the rail and the rest of the car to make it fit.
Yeah.
See, it's just a little, it's easy.